In this video, we'll talk about how to find the horizontal and vertical components of a vector. So let's check out our definition. If v is a vector with magnitude v and direction of theta, then the horizontal component of this vector, which we'll call a, can be found by multiplying the magnitude by the cosine of theta. And the vertical component of the vector, we'll call that b, that can be found by multiplying the magnitude by the sine of theta. So let's work through a few examples. Let's say we're told that some vector has a magnitude of 40 and a direction of 30 degrees. How can we find the horizontal component and vertical component of this vector? Well, we can use these definitions. So the horizontal component, we'll call that a, is found by multiplying the magnitude by the cosine of theta. So we get the magnitude we're told is 40. And then we have to find the cosine of 30. Cosine of 30 degrees. So if you imagine your unit circle, it really helps if you've memorized your 30, 45, and 60 degree angles and their coordinates. So we know that the cosine, let's say we have 30 degrees right here. We know that the xy coordinates of 30 degrees are square root of 3 over 2, comma, 1/2. And we know that the x coordinate corresponds to cosine, while the y coordinate corresponds to sine. So the cosine of 30 degrees is the square root of 3 over 2. So we can write 40 times the square root of 3 over 2. Now we can simplify by saying 40 divided by 2, that's 20. So this whole thing becomes 20 times the square root of 3. So that is the horizontal component of this vector. Now to find the vertical component, we can say b is equal to the magnitude times the sine of theta. So we said the magnitude is 40 times the sine of 30 degrees. Well, the sine of 30 degrees is 1/2. So we can write 40 times 1/2. And that's just 20. So that's our vertical component. So we can write our final answer in component form like this. V is the x, or the horizontal component we found was 20 root 3, and the y, or the vertical component, is just 20. So that's how we can write our final answer in component form. All right, let's try another one. Let's say we're told that some vector has a magnitude of 1 and a direction of 225 degrees. How can we find the horizontal component and vertical component of this vector? Well, let's start with the horizontal component. We have a is equal to the magnitude times the cosine of theta. So we're told that the magnitude is just 1 and the theta is 225. So we need to find what is the cosine of 225. So if we imagine our unit circle, here's 0 degrees, here's 90, here's 180, 270. If we were to draw the angle 225, we would go all the way around and land somewhere out here. So here's 225. So when we're trying to find the cosine and sine of an angle, it helps if we first try to find what is the reference angle, or in other words, what is the distance between this angle and the x-axis. So 225 minus 180, that's 45 degrees. So that's our reference angle. So let's think about what are the xy coordinates of 45 degrees. Well, that would be square root of 2 over 2 and square root of 2 over 2. So here over in quadrant 3, both the x and the y are negative. So the xy coordinates of 225 are going to be negative root 2 over 2, comma, negative root 2 over 2. And remember, the x coordinate corresponds to cosine, while the y coordinate corresponds to sine. So the cosine of 225 degrees is negative root 2 over 2. So our final answer here for the horizontal component is just 1 times negative root 2 over 2. So that's our horizontal component. Now the vertical component we said was the magnitude times the sine of theta. So once again, the magnitude is 1, so we have 1 times the sine, and theta is 225 in this example, 225. So we just found that the cosine and the sine of 225 are these coordinates. So the sine is negative root 2 over 2. So we get 1 times negative root 2 over 2. That is our vertical component. So if we want to write our final answer in component form, we can write it like this. The x-coordinate, so negative root 2 over 2, comma the y, or the vertical component, which is negative root 2 over 2. And that is our final answer. All right, let's try one more example. Let's say we're told that a vector has a magnitude of 4 and an angle of 10 degrees. How can we find the horizontal component and vertical component of this vector? Well, we can start with the horizontal component, which we said was a is equal to the magnitude times the cosine of theta. So we're told that the magnitude is 4 and theta is 10 degrees. So we get 4 times the cosine of 10 degrees. Now in the previous examples, we had either a cosine or a sine value where we could think about the unit circle and we could find the exact value of that angle. The cosine of 10 degrees is not really one of those angles that we typically memorize the value for. So if we want, we can just punch that into a calculator. And if we do that, we'll find that the cosine of 10 degrees is about 0.9848. So our final answer for the horizontal component is going to be 4 times 0.9848, which is about 3.94. Now for the vertical component, we'll write b is equal to the magnitude times the sine of theta. So we get the magnitude is 4 times the sine of theta. Theta is 10 degrees. And again, 10 degrees isn't really one of these coordinates on the unit circle that we typically memorize the value for, so we can just punch that into our calculator. So we'll get 4 times the sine of 10 degrees is about 0.1736. So if we do 4 times 0.1736, we get about 0.69. So that's our vertical component. So we can write our final answer in component form like this. The horizontal component, 3.94, comma the vertical component, 0.69. And that will be our final answer.